Hello and welcome back to the Feersum Scheme compiler. So in today's stream I'm going to have a look at starting the implementation of support for the scheme's define library macro or special form. So I've done a little bit of work already on actually being able to compile scheme code that we write into actual .NET assemblies or libraries, but this is different. This is the ability to have scheme code that's isolated and then can be imported by other bits of scheme code. But before we dive into that, I'm just going to have a look over what we did in the last stream. So the last stream was mainly about tail call support. So in functional programming languages, the idea of a tail call is an expression where instead of making a function call and pushing a new context onto the execution stack, you can instead just jump straight to the function that's being called, because the return value of the thing that you're calling is the same as the return value of the thing that's being of your current function. And it's used because a lot of functional iteration is done with recursion rather than by making a while loop or something like that you'd have in an imperative language. So an example a simple example would be something like lambda x, and this would be the null check. So you could say null x, so you'd say would tell you whether or not that's null. If you want to know how long something is, you could say lambda you'd say if x is null, then the length is 0, else the length is plus is 1 plus the length of x of the CUDA of x. And so you recurse down the whole thing. Sorry, I'm not used to the key bindings on Linux again. Fine, len do, and then some closing braces, and then something like this. This isn't properly tail recursive though, so what you'd say is you can define length where you use an accumulator. So you'd say like x and accumulator, and then you can manipulate the accumulator, and I've got an example of that I think already in itafact with accumulator somewhere. So here we are computing a factorial, so we define a normal function that's computing the factorial of n, and inside we have another function that has n and an accumulator, and we seed the accumulator with 1. You do the same thing when you're calculating the length. But the key there is that in this place, here, inside itafact with accumulator, this call to itafact with accumulator is in tail position because it's one of the two arms of an if, which are both in tail position. If the if is in tail position, which it is in this case because it's the last thing in the body of the function. So what this means is that when the compiler gets to here, it doesn't need to make a function call directly to itafact with the accumulator and push a new thing on the stack. It can just get the arguments for this and then just jump back to the start of itafact with the accumulator. So the way that we do that is there's no actual work in the binder or anything like that. It's just when we lower the code, when we lower an expression, sorry, not lower. I mean, when we lower it to machine code, which is compile in this compiler. So we have an emit expression with tail, which says whether or not the current expression is in the tail position. And then for each one of our different expression types, we pass on the tail context. So for example, if we have a sequence expression that's in the tail position, and then we emit all of the parts of the sequence, and then the last one, we emit it in tail position. So we emit everything that isn't the last one with tail position false, and the last one we pass on whether or not we were in the tail context. And then this flows all the way down till we actually get to emit application, which is when you try and apply a function to some argument, or some arguments to a function, whichever way you look at it. In that case, we say if we are in the tail position, then we emit this prefix opcode. So in .NET, there is or in the CIL language, the intermediate language, the opcode tail can be placed before a call expression, and that means that when the JIT compiler sees this and translates it into machine code, instead of it making a standard call, it's allowed to make a tail call. So it's more of a hint than like a mandate. So it's possible for both the JIT compiler to not emit a true tail call, even though you put the tail prefix on something, and it's also possible for the compiler, JIT compiler, to ignore to emit a tail call even when you haven't said it's a tail call. But generally, it's a good hint. And with that in place, it allows us to, if we go back to the tail example, it allowed us to compute things for really large inputs. So previously, if you were to iterate for 100,000 recursive calls, you'd end up with too many things on the stack. You'd end up with a stack overflow. But with tail calls, you're able to do those kind of levels of iteration. So in this case, the first one is actually showing something called mutual tail recursion. So we actually have two different methods. We have ping and pong defined. And in this case, so ping is a lambda that calls pong, and pong is a lambda that conditionally calls back into ping. So this shows that these can both be tail calls. So although this is the lambda bound to pong, it's not actually calling back into itself, it's calling into another one. It's still in tail position, so we can still actually jump there. So it doesn't matter that we're making a tail call to something different. Anyway, let's revert that so we don't end up saving random changes. So what are scheme libraries? So a scheme library is a way of, it's like a named group of expressions, and then some of the bindings within that are exported so that people who reference the library can call into those methods. So an example scheme library would be something like this one here, and I'll copy it and make a new one. Let's make it a scheme file. So in this case, we have define library, which is the special form. It takes this, which is the library's name, so it's expressed as a list of identifiers, and then inside the library we have basically statements which are either export statements, which says, so the export statement says whatever greet ends up being bound to by the body of the library, export that so that when someone imports it, they can reference greet. And we have an import, so in this case we say import the values from scheme base. So in this case, scheme base is our library name. So anything that was exported from scheme base, we'd be able to reference. And then we have the body of the library. So you can have begin blocks. And in this case, we just have one expression in the body of our library, which is this define expression, which is defining greet, so that we have something that's exported. So the way that we want to deal with this is, at the moment, everything that we emit goes effectively into just one class, I think. So what I would like to do is make it so that each of these define libraries defines a new .NET class. And then every time we have export, we'll put an annotation on the exported value so that we know that it can be imported. The idea being that we'll have some metadata on the class, metadata on the exported items that would say you can import these in the future. So our compiler would be able to take a reference to an assembly that's got some scheme libraries compiled into it, and you'd be able to write import statements against that. And I've shown a little bit of an example of what I imagine that would look like. So instead of it being, so test greeter, we're going to have to come with a way of making class names. Probably something where we de-sugar the scheme-like library name into something .NET-y would be good. At the moment, we don't do the world's best job of actually naming things. So when you compile, you end up with, let's run the tests and then have a look at some of the output. So in the spec bin folder, we can see all of the things that the tests have produced. And then if we do il spy on spec bin, and let's choose something. Hello, is there? Oh, the libs doesn't have any stuff yet. Null. Probably not the best example. Display. Display will do. So if we have a look at the IL for what we generate, we have this environment object, which is used for things that end up capturing a value. And then we have this scheme, well, it's a Lisp program class, which is used for things that don't. And then all of our scheme ends up being compiled down into this script body. And then if we had a lambda definition, we would end up with that there as well. So we've got the synthesized main, and there's no actual lambdas in this. But fact will do. So fact, we have the environment object again. We have our synthesized program main, which is actually always the same thing. It's basically a stub that calls into the script body. We have the script body itself, and then we have all of these methods that we've emitted for the lambdas, which are just called lambda 0. This one's lambda 0 thunk, so there's a pair of methods for each lambda. The thunk one takes the arguments as an array and then unpacks them and calls the one that takes the arguments as the actual data types that we expect. And the idea of that is that we can use the thunks to package up inside delegate types, funks, and box them up and put them on the stack. Or heap, even. So the way that we're naming these is that because when we're emitting the lambdas, we don't actually really have any naming information associated with them. We're just calling them lambda 0, lambda 1, and if you then end up with nested lambdas, you'll end up with like lambda 0, lambda 1. It can just get as long as it wants to. But for at least the actual overarching library, we could probably come up with a name based on the fact that the library actually has a name. The problem with lambdas is the fact that in this case we're doing a define short form, but you could actually write define fact as lambda x n, and then the same body here, and that would end up being the same code, because all the other form is a short form of binding a value to a specific lambda. So in this case, define is saying bind to the value, well, bind to the symbol fact this value, and this value doesn't actually have a name, because there's nothing to stop you from then later on going, you can't say that necessarily that lambda is called fact, because you could then do set thanks IntelliSense facts, and just, it's not even a lambda anymore, it's now a number. So just back all of that out. With libraries, we don't have to worry about that though. So the best place to start here is when we are binding libraries. So we need to recognize the library form and turn it into some richer representation of what a library is. So I'm going to start by having a look at the actual spec itself and seeing exactly how it defines a library, because it's a while since I read it. So program structure and libraries. A library takes the following form: define library, library name, and then library declaration. So we're going to end up with like a bind library that expects define library and then library declarations. So it's going to do bind library declaration on those. And so a library will end up being a pair of a name and a list of library declarations. Let's start there and see how it ends up. Yeah, I think that should be syntactically valid. So I might just comment this bit out so that we don't have to worry about bind library declaration at the moment. And then in binder, we have probably library of string list and bound if we let's just make it library name for the time being. I think the type's going to have to become mutually recursive with something else to be able to, because a library declaration is probably, it is going to contain expressions. So at the moment, like storage references and things, yeah, we might end up with those ending up as references to libraries as well. So the whole thing might end up mutually recursive types. Wonderful. So in the binder, we have a big switch somewhere over all the special forms. So do we already have one for define library? Nope. So let's just copy this. Let's copy the one that's actually been written out already. So if the kind is define library, body should be an we don't necessarily care. What that is. At this level, maybe we just want it to be a name and a body. And then we can do a bind on that. So we're expecting ID. How about let rec? Yeah, that's just doing bind let, passing everything in. Lambda does formals and body. Yeah, so we'll do it that way. So we're expecting two things. Name, body, and we'll say let bound name bind library name, and then we'll leave the body for the time being. And So if we have that return a result, we can say match name with, okay, bound name. Then we'd bind body, but in this case, we're just going to turn that into a bound expression library name, bound name. Otherwise, we want to turn that into diagnostic. We can do this bit, just diagnostics add, and then return an error. So that the expression can't be used elsewhere. What on earth have I done here? So fill form define library. That, and then let's go sort that out with Git. Yep, we'll have that. This bit is where I messed it all up. I'll have that as well. So I need to define bind library name, which I'll just put here. Ooh, match name with we can probably emit our own diagnostics rather than what are you upset about? Convert. Do you want it to be bind or parse? It might actually be better to do it as a parse library name. Then we can just return a list of strings. I think there might actually be other forms that you can do for library naming as well, so we'll handle that later. So we'll say if it is a list of bound expression list it's expecting us to create a diagnostic, so we'll say anything that isn't a list, we'll just say name location. Do I need to tell it that that is a bound expression? Maybe. Bound expression does not. It is sequence. But it's not going to be a sequence. It's going to be st node. So it's going to be st node kind list, which is form, obviously. So if it's a form, we'll do something. Otherwise, we need an error expected. So if it's a form, we're going to map it, I think. So that will be x list.map. And we'll have this as parse library name, or should we just see parse name element? I can make this out local. Or we could even just have it as a lambda like this. That's not how you do lambdas in this language. That's going to be there's some helper method I wrote at some point. Not options, utils. Collect. result ex.collect. Find with if it is an ID name part otherwise is it a symbol? Ident, obviously. So now this produces either a list of string or diagnostic, which is what we want. And then hopefully that should mean that our binder kind of works. In which case, let's run the tests and see what we end up with from the parse of this library. And it's going to fail. Incomplete pattern matches. Yeah. So the emit code's not going to work because how do you lower a library? We haven't told it about that yet. And that is in emit expression, but we can leave that for the time being. We'll do update task, run task, update snapshots. So that should generate a snapshot for the libs.scm, and then we can have a look at what it looks like in the actual, is it the specs folder? It's in the test folder, snapshots, parse libs. So we end up with a sequence containing a form, containing the ident, define library, span, blah, blah, blah. Then we obtain a form with ident. Okay, so the parsing, I forgot, is actually only up to the abstract syntax tree. So the parse tests aren't going to pay any attention to the bound nodes. To actually do something, we'd need to lower it, which is in compile. So we'd have to have an emit library. Which I think can be fairly simple, to be honest. emit expression. So if we get an expression and it is, let's see what order we've got everything in. So in this one, we've put library after lambda before error. So we'll do the same thing here. Bound expression library name. We'll probably want something else later. Emit library context. Hey. And then we'll pop that declaration at the bottom. So is this, yeah, that is. I want to find the last one. So emit named lambda, I think, is the last one in our chain of mutually recursive functions. And emit library context name, which is just going to do emit unspecified, I think, for the time being, because I'm not sure what the library actually wants to evaluate to. This value is unused. Emit unspecified, fine. So emit library should return unit, right? And you just out of date. Nope. Great. Can you tell I haven't written F# in a while? So now, I think we should end up with passing tests again, because we're not actually doing anything wrong here. It's just that if you write a defined library, we will kind of just ignore it. So long as your library name is correct. So let's have a quick look at what you can have as a library name, and then we can write some error tests that check for bad library names. Library name is a list. Members are identifiers, non-negative integers. I think we can just ignore the stuff about scheme and SFRI, because that's just saying don't use these, but we want our libraries to be able to be used to define the actual scheme standard library as well. So we want our compiler to be able to compile something that does do define library scheme, if it does, the trusted people defining it. just thinking about all of these characters. Inadvisable to use, but not an error. This is kind of getting to the point where we could do with the severity on our errors. So at the moment, a diagnostic, I think, has a location and an error. What we could do with is a severity on them to be able to emit something that says you really shouldn't have used this, but we're going to continue. Do I want to delve into that now? How many places do we make diagnostics? I suppose you could have like an add with severity, and we could have like a diagnostic with severity, which has, and hopefully everyone uses this. I think this is a job for another day, though. The one thing we did get there is that we do want to support libraries that contain numbers. So let's just do an example of that. Define library. It should support numbers. That's going to fail to parse at the moment, but it shouldn't. Line 1, column 28, line 1, column 31. Invalid library part. So, oh dear, need to sort out this camera. Hopefully that's a bit better. Bit more secure. So where we do bind, we do parse. Library name. Parse name element. We need to support number. And we can just convert these to strings, I think. Two. That'll do. It is constant. We only need to support numbers. So let's just nest the pattern. That'll be good enough. Well, it's going to make it pass at least. Then we can come up with some errors, I guess. So we can put spec fail tests. Does the list have to be non-empty, I wonder? I don't think it said it did. That's not going to be valid. What else could we think of? Just a dot. That's also not valid. These are good because you generally get to see what the errors are. That's not good. It doesn't look like we've actually got any errors, so or is this the parse part of it? And then there's also yeah, okay, so the errors are down here. Diagnostic. So it's gone expected library name, and invalid name part. So that's in this order, isn't it? That's not a library name. That's not a library name. This looks like it could be, but it isn't there. That all seems totally acceptable. Let's just state it all. Then we need to bind the body of the library. So these are called library declarations. So let's go to the binder. Bind library. Bind. We got parse library name. Do we want to do bind library body? How deeply do we normally nest this? Yeah, like bind lambda body is passing in the formal, so I think I'm going to go the same route. Context, name, body. That's actually going to be bind library body. Then we can have it, at the moment, we can do bound expression library name. It currently does. Down here, we would pass in bound name. And that needs a context and the body as well. Then here we can do body. This dot map. So we'll map it with bind. Does that need to be mutually recursive? I don't know. So if we just bind everything in the body to produce something, we need to decide what type that is, then we put that in the library. So bind lambda body, bind library declaration is probably going to be something like that. Then we have parse. So we got storage. We've got literal. We've got expressions. Library declaration is one of the elements. No, that's a bad way of saying it. Library is made up of one or enough. Type bound library declaration is going to be import of well, what is it? Export, import, begin, include CI, include library declarations, and const expand. An export declaration specifies a list of identifiers, identifier or identifier renamed. An export set an import declaration provides a way to import. It's the same syntax as the import declaration used in a program. So I think it's basically going to be export declaration list or import declaration list. So let's do those first. Type bound export declaration is plain of string renamed of string. I think. Yeah. Single export from a library declaration. So then this could be export of bound export declaration list. Import of bound import declaration list. And so you can have a plain import. What else? You can have an only and an except. Fair enough. And a prefix and a rename. So just a plain import, yeah. Then you can have an only which is going to take a bound. We need to say bound import declaration there, don't we? Except, which takes everything. So it's going to say import set again. Should we call this an import set? Yes, probably. Bound export set. It should be, no, not rename string. Bound import set. String list. So it's the same kind of thing, but we're filtering things out. And then you've got prefix, which takes an import set and a single identifier. And the last one, rename, which takes a set and then a list of pairs of identifiers. Do we want to make that a type? I think we probably do. I think it's going to be a single element. And this can be bound rename, and then down here we can say renamed of bound import set bound rename list. There's also a whole bunch of other things that we could have, but let's just do import and export declarations for the time being. So up where we have parse, we should have bind library. Do we have an error type that we can use in this case? Let's just stick one in. So if find, it's going to be an ident export. So to say anything else becomes bound library declaration. No. Is it bound library declaration? Yeah. Dot error. Find export declaration. Take a context. That's the imports, my exports. The actual library is taking a list of these. So probably going to want to take a context and bind them individually. What are you upset about here? HT no kind. Are you sure that you don't expect ident to have... Oh, because you're actually expecting that to be this, like this. Define library. And that is expecting. Oh, I see. Yeah. Okay. That's doing the match against the kind like that because we're expecting an AST node list, not whatever that was expecting. And then you want to do by declaration. And expect this to actually be a form. Like that, which is really not very elegant. What's export expecting? List of bound expression sets. So if we do export list.map, find export declaration. That. And then we do and plural. Then in here we can say match so an export is either an identifier or a rename. So if it is an ident, just plain. For the time being, everything else can be context dot diagnostics add, and then you give it an oh, you can do emit, can't you? That'll make it easier. Position is going to be export dot location, and then the message is going to be I will construct a bind export declaration. Right? Why not? Let rec. Fair enough. So based on that, I think we should be able to uncomment some of this if we do export that. And we'll rebuild the compiler, rerun the tests, and see what that ends up producing. Ah, yes, we need to update the where we emit this. We expect a name and a body for the library. So we'll pass that all the way along. Still emit unspecified. Take the snapshots. Great. Are you the error? You're the error. Yep, because that's not the syntax for that. Okay, still going to use the qualifier. Makes everything else look neat. The problem we have with some of this code, and the reason why we have so many prefix qualifiers, is cases where you have really common words like if, which exists in lots of places, seek, literal, and also error, which then ends up actually conflicting with result.error as well. Just for funsies. That's why you'll see lots of matches that do okay on one side and result.error on the other, which really should be result.okay and result.error, but whatever. So I think that should be us binding export declarations. So if they are a plain export declaration, we need to do renames as well. If it is form and what is a rename? I think a rename only takes, yeah, it's a form where the first element is kind is a rename. The second one, kind, is an ident from. The last one is the ident to. Should we call those old and new? What does the spec call them? Identifier 1 and identifier 2. Rename spec exports the binding defined within or imported into the library and named by identifier 1 in using identifier 2 as the external name. So we can call them internal and external. No. Close enough. We need an arrow at the end here. So that needs to be ident. So if you have a rename with 2 identifiers, we want to do bound expression set dot renamed. I'm wondering if we want this bit to be a separate method as well. I think it just needs to take those 2. In fact, we could probably just match that. For bind rename. And then pass it on to renamed, and then we'll have a bind rename. Which will do rename, which is going to be a list of nodes. It will either be y just copied, in which case we do bound rename the internal to external. And let's have it try bind rename. Because we don't really have any decent place to put the diagnostic information in here. So that will either be okay with that, or any other pattern will be an error. Invalid rename, so we can do try bind rename. Don't need the context there. And then we can do salt ex dot collect, and then yeah. Do we need an error? The export set as well. How do we make? Do we make it result based? Well, I'm gonna go and make myself another drink, and I will be back. Hello. Right. I've had to think about this, and I think we do want bound export set to have an error kind, because if we take it that we've got like an import or an export, these are a list, and if one of them is bad, we would like to record an error for it, but we would also like the binder to be able to carry on and do best effort. So we're going to need as many of those imports or exports as we can. So like if you take the example program where you're trying to import something and you've messed it up, yeah, we wouldn't be able to compile any. We'd register errors for the bits where you've tried to reference the value that you failed to import, but the rest of it should be okay. And I think that is close to how like the F# compiler would treat this whole thing. So like, for example, well, we've got the result.ex stuff here. If I don't actually want to be using result.ex there. So we've got result extension collect, and result extension is coming from utils. So say I mess up utils and call it something like utilities, right? We'll end up with an error here. The namespace could not be imported, or it's not, whatever. And we end up with an error here saying we can't find result.ex, which seems kind of acceptable, really. So let's do the same thing. So we've got the bound export set renamed, bound import renamed. We'll put an error kind on both of those. And then down here, we'll do try bind rename. And if that worked, map with renamed. So now we end up with a result. Is that right? Let's just do a match. Match. Renamed Otherwise, we'll do add context.diagnostics.emit at this location. I'll rename the list. Export.location, I think. And then might as well pass on the error from this, which is a string. Fix that up. And then we need this to return bound export set error. That, I think, is the export declaration parsing. And this down here can be error. So if it's plain, it's plain. If it's rename, we try and bind as a rename. If it works, we do rename. If it fails, we log it as a diagnostic. So we want to do and bind import declaration. Make that an error for the time being. So when do we do export exports? Are all of these elements going to be a form containing some keyword? Yeah. And then a list of things. We're only really going to support these first three for the time being. But either way, it's always going to be a keyword, an identifier, and then a list. So I might split out the parsing for the form with the parsing for the actual declaration. So bind that. If it is a form, body special, I think, because it's a special form. And then bind library declaration, bind library declaration form context special body. And I think we might also want declaration.location. you should log an error down here as well for stuff not being correct. Diagnostics, emit. We want to emit at declaration.location and expected library declaration. And then we can move this bit now into bind library declaration form. Get the context, position, special, and body. And it's going to do match special with, in this case, rename. I'll do this. Export, export body bind as an export. Then we can do import and we'll implement that in a second. Otherwise, emit diagnostic. And we'll do that at the position, and we can say we'll do this with a pipe instead. Valid or unrecognized library declaration. S. And return bound library declaration error. So that's how we get the error type out. So now we just need to do the same kind of thing with the body of the import. So we'll do list.map again. Bind import declaration. Bound library import. Then we don't have a bound by import declaration yet. Oh, we do. It's just an error. So match import.kind. Then we can just do the same thing as we do for the exports, saying it's an invalid import. Import set. But now we need to have a look at all those different ways that you could import things. So we have plain when it is a library name. So that's not an identifier anymore. Prefix. I think we're just going to have to fall back to trying to parse it as a library name. I'm going to take any other one as an import. We have our parse library name somewhere, which takes a node. Yeah, cool. So this is AST no kind. These are all going to be forms, I think. Where, and then we can do only. Only accept prefix and rename. So we've got only. What I kind of want is only And then from set, and then filters. But is this a valid pattern? So that's an AST node. That's an AST node. Can I just put some more brackets around it? It's a list because it doesn't know what it is. Could you rest parameters in a list like this? No, because it thinks that's a list. Right. Maybe we need to parenthesize it the other way around. So we have the pattern for the head, and then we cons it to the pattern for the tail, which is a cons pattern like that. Maybe. That's because it's not an OR pattern. Bound input set only. Bind import declaration. Bind identifier list. Wondering if I've got a list already. Some kind of parsing, because we would have done it for something, surely. Lambdas? Bind formals list, which is define kind of this doesn't need to be mutually exclusive like this. Let's pull it further up. Find a library declaration. Find a list of identifiers. Yes, idents. Parse ident. So if we do that, then we could do result ex dot collect dot is it result bind? Oh, that's combining two results together. I want an unwrap or. Let's so if we get some idents, we return the idents. Otherwise, if we got an error, let's make this parse identifier list. If it is an ident, we return the ID. Otherwise, return error. Not just of the unit type. Do we? Or you can make a diagnostic. Because we have the value. Yeah. So we could do diagnostic node location then if we've got an AST, do we have any nice way of summarizing it for an error? Let's just paste it in and find out. I'd like to have something like this where it just says I was expecting, but I got an if ... or whatever. Let's just do expected identifier. Then if we get a list of idents, that needs to be parse identifier. We'll then end up with, come on, catch up compiler, that binder result being a list. In fact, let's just do that. So we've got parse identifier list, which is just going to take the idents. Then I want to let they'll give us a list of strings or a diagnostic. I mean, it's only going to point to the first thing that wasn't an identifier, but we'll leave that for the time being. That should be good enough. Then where did we actually want to use it? This wants to be match parse identifier list filters with okay filters, in which case we do what we were previously doing. Otherwise, if we've got an error, add the diagnostic and error out. That must be result.error. So that's only except is the same form. I'm just going to duplicate this and we'll see where we end up being able to abstract some of this away. So that is except we also have prefix, which is going to be similar again, but we don't have to use this fancier pattern because we can do if it is prefix from set prefix, because we know it has to be those three things, and you want this to be parse identifier prefix prefix. Let's rename that. It's kind of looking like there's some commonality there. And rename, which is going to be similar again to one of these ones where it's got a recursion thing. But that's going to be rename, and these are going to be renames. And then instead of that, it's going to be parse rename, bind rename. Try bind rename. let bound renames equals renames try bind rename collected, and then we can bound renames renamed the block for this let unfinished. Renames maybe. Pretty certain that's the same thing as function. What are you upset about now? Because that needs to be kind like that. And it's upset because that's offset match. Doesn't look very nice. Interesting. It thinks that from set is not used as well as bound renames. So what has gone wrong here? So renames is a list of AST nodes. Yeah. Now you're upset. It's definitely too long. It's got to be a nicer way of doing that. Unexpected infix operator in binding. Great. I've lost it. Back through the history. Then what are you upset about? So parse rename is a function that takes an AST node and returns a result of bound rename or string. Renames is then a list of AST nodes, and we do list.map parse rename. So that why does it think that is a bound import set? Do I just need to recompile? I mean, I assume it thinks it's a bound import set because it thinks this is the end of the block, but it isn't. Surely this match should be the end of the block. It's not that, is it? Yep. Diagnostics, emit. And No, we'll make them into diagnostics earlier. So here we can make try binary name. We can map that result. Why are you not going any further? Result map error. So in this case, want to map it by diagnostic. Node. I'm gonna have to take the node so that we can do match node with, and then I think we found out the reason why everything's indented badly. And we can do try bind rename result error diagnostic node location. Hopefully that should end up with expected to have, but here it has type diagnostic. Does it? It is because it is a pair. Great. So because diagnostics expecting a pair, we have to do this the hard way. Diagnostic node location x, and then we need to wrap that all up to make it a value so that map error happy. So that's now a boundary name, and then this wants to be diagnostic as well. Again, node.location. Might be able to get that all on one line. Can. So if we've got parse rename, bound renames is passing all of the renames. Is that really binding? It's returning an error. I think let's try parse rename. And then once we've got the renames list, I think that's kind of it. What are you upset about? I think that's an old error. I think that's from when I did diagnostics add with a string, and VS Code just hasn't kept up. Right, so now the problem is, if we have all of these different forms, what is actually the same? So, like, really, this bit is the same as this bit. So, how can we make this look more the same? So I guess we have parse rename. Parse renames is gonna be this. We can make this private, like that. Get rid of that, and then we can do parse renames names. So then we have this bit here looking like this bit here, looking like this bit, like that bit. This is taking a single one. If we change this to look like the rest of them, we're gonna have parse prefix. Prefix is gonna be match prefix with kind form, kind form we can just say we expect a single identifier. And return that as the prefix. Otherwise, return an error at prefix. Ooh. Maybe we're gonna have to take a location. And then expected identifier. Then we can do parse identifier. We don't really have a great location there. Should we use the location for the whole node, the whole import? Expected single identifier for prefix. We do that, and then we can do import.location. And then we could do parse prefix instead of parse identifier. Then we can make this take a location, which we ignore. So that will parse rename, which would be import. Sometimes you have to write, you have to make code longer before you can make it shorter. So then down here, parse identifiers list. Yeah, I think I get the idea of where we're going now. So have we made that worse? Let's see. Let's leave this just using parse identifier and having a fixed thing for the prefix and come back to it. So I think with that, we can make this rename, move that up, then anything that isn't that is going to be treated as a library name. So we want bind import form, maybe? I'll just copy one of these. Filters. They're all taking pairs, so I think I can do something like this. So bind import form would take binder and results. Then we do something like this. And body can then be like that. Then this wants to be result collector. So now we have bind import form. Can we rewrite this as bind import form? We do bind import form. It's expecting a binder, which is going to be parse identifier list. Then it expects the from set and the filters. And result cat is bound import set dot only. So then I think we can do the same thing with except. And then parse renames, and then do this. Parse renames from set renames. Okay, so that's kind of looking correct. So does it takes anything that produces a result? So I think we might be well, do we move the pattern for the tail inside? No, let's leave it like that. So then we can do the prefix one as this. Find import form parse identifier from set prefix like that. That kind of works and is shorter. And then down here we want to match parse library name, which is expecting a node. So if it is okay, found import set dot plain name result error. What's that gonna do? It's given us the diagnostic, so I guess we just want to add it to the bag. What's this subset? Lib is a kind. Parse library name is expecting a whole identifier. Sure. Name is a list of strings. So that actually wants to be list. Do we have a better representation for a library name? I don't think so. You can make a bound library name. But we don't really need it right now. I think that is probably it. So let's just run the tests. That's the build. So we have our bad library names. We have imports and exports. So we should be able to do define library test first. We should be able to do export. Do they have any examples? So that's got an export, including a rename. It's got an import. So if we just make this like that. There's Buzz. Then we would be able to do begin, define Feers 100. Let's just do them as constants because they're easier. And then we should also have another element that isn't exported. Not that we're going to deal with that body bit yet. Then we should be able to parse and bind that. Nope. What's gone wrong there? Missing, closing. Well, I mean, yeah. But that doesn't seem fair, does it? More errors? Unrecognized library declaration begin. Fair enough. No, spell begin correctly. And then we can just fudge this for the time being. Bound library declaration export of an empty list. And we can say to do handle begin or handle library bodies. So binding the body of a library. That's going to be interesting. So I think what happens is we're going to like bind the library declaration. We're going to have to create a new context to bind the library in. And then the library can define all the things it wants to do. And not the library declaration, bind library itself. Where's this called from? Yeah. So bind library body. we're going to want to like create a new context, bind the library into that context, and then once we've got the bound library, it will have all of its imports and exports. We'd be able to then add all of the things it exports into our scope, which means we're probably going to need a new storage ref type, because we've got built-ins, globals. Globals are used for static fields. Built-ins built-ins might do it, to be honest, because the built-in is basically a reference to something else. But it is a method. Whereas ours are going to be fields. Static fields. So we'll probably want like a storage reference local, unless global becomes something which, this is the emit context here. So we could have the library type as part of the global. Then when we do ensure field, we'd be ensuring the fields on the global. Where else do we reference global? No, not implementations. Go to references. So when we add a binding, interesting. Yeah, it wouldn't have a parent, so we would be creating globals for them anyway. We just need a way for the library class so that we don't end up with name collisions. Anyway, what is going wrong down here? We've still got unrecognized library declaration. That's looking far more promising. There you go. So I think that's it. I think that is initial library support. parse the form and import and export library declarations. Still do is support for begin. So we'd have to have the begin declaration reference expression somehow or other. That's going to become awkwardly recursive, I think. So I think bound library declaration would then have like bound library declaration of begin, which would be of expression list, which then means it needs to be mutually recursive with bound expression. Well, we can do that. Because expressions can contain libraries that can contain expressions. And then I guess the root, the actual library scope that is the overall script, could potentially at some point become the root expression. It's like when you parse it, you would end up with like a bound expression. I think at the moment you get a bound expression sequence with whatever you have in it. You could end up with a bound expression library. Yeah, I'll have a look. So, what have we done today? We have added support for define library form. So we can now parse the define library, the library name, and then import and exports. So we do that in the binder. We have some new code for parse library name. And we have this bind library declaration form, which is supposed to handle all the different kinds of forms that you can put into a library. So we've got export, where we look at each element in the list and treat it as an export declaration, import, which does the same thing but with import declaration. And then we've stubbed out the handling of begin so that we just don't end up with parse errors, but we're not actually going to do anything interesting. And when it comes to the actual compile, when we get one of these libraries, at the moment we are just emitting unspecified, so let's just handle that. We should put to do in here. To do lower the body of libraries. We're going to need to teach the compiler part of the whole thing about which type it's currently compiling to and have a cache of other types. So when we emit at the moment, we have this context program type, and we will want to change that to be like context, so that we can create a new context with a different program type, maybe. Because I think program type is the Lisp. Yeah, it's like the outer class. Separate. It's not instances, types per library. Okay. So, thanks for watching, and I'll see you next time.